Thank you so much, everybody. Handing over to Priyanka, she'll be starting off with the session now.
Good evening, everyone. So I'm Priyanka. I work with DataTorrent, and I'm also a committer to Apache Apex product. So let's start today's session. In this session, we are going to see how can we do deep learning processing using Apache Apex. So here is the plot for my talk today. I'll first quickly share what Apache Apex is. Some of you are new to our webinar series and may not be very familiar with Apex. So just let me take a couple of minutes to explain what this platform is. Then I'll talk about what is deep learning. We will see like the library. We will look into the library which we are using for integration, which is DL4J or deep learning 4J library. Then how do we use them together, the library and the platform, the architecture or the design of integration. I have some screenshots from the demo. I don't have a live demo right now, but I can show you some statistics, the screenshots we have, and I'll just talk about some challenges we faced during this integration. At any point of time, if you have questions, please type in your questions. We will take some logical break and answer your questions as and when they come or at the end of session. So Apache Apex is actually a platform to do real-time processing on big data. So it actually enables you to develop your scalable and fault-tolerant applications or products in a distributed environment very easily. So the platform is Hadoop native. When you want to use this platform, you need to have Hadoop in your system. This platform can be used for your stream as well as batch use cases. The platform actually promises very low latency. So if we have seen in fields, like people have achieved the latency of less than few milliseconds in production systems. We also have a very good library which is called as Apex Malhar, where we have a lot of operators which are ready to use consume operators in your application. So example could be, we have a lot of operators to read from different data sources. We have minutes processing operator and as well as operators to write result back to a lot many different destination systems. So we have this rich library which makes application development very easy. And we also, other than that, we also have capability to write your own business logic to do something customized in your applications. So we also have application templates where you have like we have identified some basic or common use cases across industry verticals, and then we create the application templates out of that, and it is hosted on our app hub. So if you go there, you'll find many ready-to-use solutions which you can use directly, or you can do some customizations and use them. So this is about Apache Apex. I won't go into very details because we keep covering that in different sessions, and our focus today is more on understanding deep learning. So let me get started with this. But meantime, if you have any questions about Apex, I'll answer them for sure. So what is deep learning? So deep learning is actually it's a type of machine learning only. It's not a new science as such, but only the difference is the kind of algorithms deep learning has. They try to model in a way that they want to have high level abstraction of data, which means it doesn't go for example, if it is analyzing pictures, it doesn't go pixel by pixel to understand something. It will try to do a high level abstraction. It will try to recognize the bigger structures. For example, if it is a human being image or face image, it will try to recognize your nose, eyes, and everything instead of working at pixel level. Then deep learning eliminates the need for feature engineering. It actually works very well with unsupervised data. You don't need to hire a lot of data scientists to extract out features of your incoming data and then feed it to algorithms. A beauty of these algorithms are they do self-learning. They do decide which features to train on, and they do it itself. And if you see this graph, if you compare any other machine learning algorithms versus deep learning model becomes better and better when you feed a high volume of data. So as you keep training it, it becomes much and much better. And just to look like what technology this the deep learning uses. It's nothing but neural networks. So neural networks are actually modeled behind human brain. They are meant to work like a human brain, like they do object classification, they do take decision and everything in human brain like format. And this is the structure they have. Like you have any neural network will have an input layer where you get data from outside system. Then they have multiple hidden layers where a lot of processing will happen, and the output layer where you get results. Uh, and in any common deep learning algorithms, you will have multiple hidden layers. The more hidden layer you have, the better result you could get, because these layers could learn or train themselves on different features, and like more layer you have, the more training will happen. So and normally you will have a lot of layers, and this is how like the deep learning algorithms use this brain-like structure algorithms called neural networks and do training. And these are some of the applications. So you must be wondering, like, where do I use deep learning? So deep learning is used in many areas. I have just mentioned few to give you some idea, like where all it can use. For example, object classification. So for example, you are feeding a lot of images to the algorithm. For example, they are fruit images. So over a period of time, it will start recognizing the orange, banana, apple, and lot many other food pictures you provide it, and it can do it itself. You don't have to provide any feature set to it so that it can work on those features. It does self learning. Then image caption generation. So Facebook has this feature for, so when you post a picture, it will actually analyze it and have some text representation. For example, if your picture has a window and beautiful mountains outside, it will write a window overlooking beautiful mountains or something like that. So Facebook uses deep learning for such things. It can be used for automatic game playing, handwriting recognition, adding sound to silent movies, which is as good as lip recognition. Google has some product which uses deep learning libraries to do lip recognition, colorization of black and white images, and there are many more if you would like to see. And from my experience, deep learning works very well for images, audio, and video files, and especially for classification and other things. So these are the applications, and I think many people want to do something in these areas, and that's why like deep learning is picking up a lot nowadays. Now to use these deep learning features, we wanted to use some library where most of the algorithms are implemented. Sure, there are many deep learning libraries out, and we chose to use DL4J. I'll run through the reasons why we chose this library. So the first reason was like it is open source, yeah. So it's there are no restrictions. We can use it easily with Apex product. The most important feature is it's distributed. So Apex, as I mentioned, it is a distributed platform. It works on top of Hadoop, and when we run the algorithms, it suits best if the algorithm itself has distributed nature. And most of the machine learning algorithms are not distributed in nature. So this is a very important factor about the library. The algorithms they have written are meant to be distributed. You can either run them in parallel threads, multiple threads on the same machine, or you can use multiple machines in your cluster. Then the library is written in Java and Scala. So the Apex platform is written in Java, so it's easy to integrate. It already has some integration with Hadoop. It uses Hadoop for data access, which is again a very good uh, reason for us to choose it. It also has commercial support. So SkyMind is a company which has written this library, and they have a commercial support. So if you really want to go to production using deep learning, I think it's very important that you have some customer support or commercial support. And it actually has developed most of the machine learning algorithms which are used commonly. To name few, it has LSTM, convolutional neural networks, restricted Boltzmann machine algorithms, and many more. So most of the common algorithms you use are already implemented in a distributed fashion. So these are the few reasons we found deep learning very useful, and we started to look into it to do our deep learning processing. And this is how overall picture of deep learning. So deep learning Basically, any that like deep learning library actually can work with multiple data sources. For example, data input sources, pictures, audio, video files, and many more. But sure, your machine learning algorithms don't understand all these data formats. So you need a way to convert these input sources to a form which the machine learning algorithms understand, and that form is normally vectors. So they have a library called DataPack, which can convert your input data format and different input data format to the vectors which machine learning algorithms understand. After this conversion, the data is handed to this layer called ND4J. So ND4J is there actually the scientific computing library where all your algorithmic computations happen, which are required to run the algorithms. And this library is written in native code, and they use Java CPP to interface. And actually, they claim that it is even faster than NumPy, which is in Python. So they say it's almost twice faster than Python. And then there are some data access layer, Hadoop and Spark. They use Hadoop and Spark to access data. They can run on GPUs as well as normal CPUs. If you use GPUs, of course, you'll get better performance, but you can still run your algos on CPUs. And the output will be the model which you can use for the scoring ahead. I'll just pause for a minute and see if you have any questions. Okay, I don't think there are any questions right now, so I'll just go ahead. So why we thought we can use Apex, deep learning with Apex. So training deep learning algorithms on a single machine, it's very time consuming. It could take really literally hours or days to run these algorithms. The advantage of the DL4J can work with multiple CPUs or GPUs, and we can take this advantage and then use Apex, which actually has a cluster with multiple CPUs and GPUs, and run these algorithms on top of Apex. And if we integrate these two, we feel that the time to train as well as score can be improvised by a very large factor. That's why we are trying out this integration. Okay, now I'll just talk about how the architecture looks like what is the design for integration. So there are two ways you can do parallel training for deep learning. The one way is you can do model level parallelism, where part of your model is distributed on different machines and you do processing. And the other way is you provide the models to different machines, and you partition your data. Out of your incoming data, you can send subset of this data to each of your machines which are doing processing, and then uh, you can use some mechanisms to come up with a final model. So we are using the second approach, which is called data parallelism. Here, what we do that we initialize some model with default values, and we send this model to all the data, all the processing node. Let's call them as worker nodes. So these worker nodes will get these models, and each node will get subset of incoming data, and they will train their model based on incoming data. So this is the way we do a parallel processing. I'm sure you have many questions each machine is training their own model, and you don't want to come up with 10 different models with 10 different type of accuracy at the end, right? So we are using some different mechanisms to take care of that. So as I said, we have many worker nodes, and they train themselves on incoming data with starting with the same model. But over a period of time, as data comes in and they keep training themselves, this model is going to be different on each worker node. But at the end, we want the same model, right? So what we do, we have a mechanism called parameter averager server. So at fixed intervals, we keep sending this trained model, which are also referred as parameters, back to the server, parameter averager server, where these models or the parameters are averaged out, and a new model is formed based on this, and this new model is pushed back to the worker. Now all the workers are again on same page, and they start training themselves on next new incoming batches of data. and this again after a while they will have built different models based on what data they get. Again it will be averaged, and this process keeps running for a long time to get a better model and leverage the power of parallelism, do the processing on small amount of data, still combine all the results and get you the final model. And this is the Apex application DAG. I'll just again pause for a minute. So there are, I think, a couple of questions. Example for the deep learning, or can you be specific? There is one more question: how Apex is better than Hadoop components or Spark? So I'll just, I think these are two questions: how Apex is better than Hadoop and how Apex is better than Spark. So to compare with Hadoop, Hadoop is mainly about batch processing, and they also have introduced YARN, but they don't have any directly consumable platform or product as such. So we actually use Hadoop to do our processing, but we provide you a layer or a platform where you can use all Hadoop capabilities, as well as on top of that we simplify a lot of development efforts for you. Also, we provide a framework, so if you use that, your applications can be written in a streaming fashion. You don't have to take care of tons of things you otherwise will have to do when you write your streaming applications. So Hadoop, instead of comparing, I think they go hand in hand. They help each other and enhance the platform and give you better capabilities to write your application. And comparing with Spark, there is one thing that Spark is not purely streaming. It's I think batch processing, and actually we had actually session where we did a deep dive into the comparison. I'll maybe provide some more resources to you offline. How often the parameters are averaged? The next question is from Joseph. So actually this frequency will depend on your incoming data and a lot many other factors. So we are just in initial phase of development. We haven't tried on different data sets. So I don't have a very good answer to it right now, but I think we'll have to tune out that interval. It cannot be very large and it cannot be very small as well, for sure. But we have to come up with a good number. Is Apex only for deep learning or Hadoop? No, Apex can do a lot many other things than just deep learning. Apex is used for ingestion. It is used for different use cases. Let's say your ad network use cases, your security use cases, fraud detection use cases, and there are actually a lot more. If you go to our page, we have actually listed a lot many white papers. Deep learning is something actually we are trying the new thing on top of that, and we also have integration with Samoa library, which has machine learning algorithms implemented, and deep learning is work under progress. We are still trying it out. The next question is it fine to average parameters even though the training data is different? For example, garden images, industrial images, does the averaging still hold to be successful for different kind of images? No, actually, when you do this training, you normally do it on similar kind of data. For one data set, you actually run this training once. So today you are training on garden images, you do that run. Tomorrow, if you want to run on some different data set, you stop that, you fetch your model, then you can use it for scoring, and then you use for other images. Because or in general, if you want to differentiate between garden and industrial images, then yes, you can use the same data set and it will work. But if you want to have some use cases, for example, in garden images, if you want to differentiate between different flowers or different trees, then maybe it's not a good fit. So I think it's okay to use to mix the images, but it depends on what intention you have. Does it work with Python? Actually, we are coming with Python APIs. So if Apex has Python API, I think yes, it should work in future. So you need to, one more question. So you need to build a different model for each image type. Again, question is yes and no. It depends on what your intention is. If you want to differentiate between automobile versus garden, then yes, you can use same data set. But if you want to do more only around gardening, then better not to mix them. I'll say that. What average function is used? Actually, the average function is simple average, mathematical average. It's nothing very fancy. But the DL4J library has other techniques than parameter averaging. Uh, Truly speaking, I haven't read thoroughly into that because for the first part I wanted to try out simple thing. But there are other model aggregation techniques. Uh, but I'm not. I don't have the thorough knowledge of that right. Okay. But you can actually easily get it if you go to Deep Learning 4G Lab web page. You will get a lot many of that right away. एक एक करके देखो an example of for how parallel model works. I have some maybe demo screenshots and example data input. I think that will make it clear when we run through next slides. I think that's all questions we have right now, right? Can you do one thing? Can you show? Okay, we are not answering. Anyway, just solve them with time. So one more question. So we cannot do classification models other than binary classification for given model. No, you will need I'll just read out. So question is so we cannot do classification models other than binary classification for given model. You will need a set of models to answer complex questions. No, because you can do a lot of other complex classifications. It need not be binary always. So as I said that it learns on itself. So it depends on what. So if you want to tell your algorithms what it has to learn, then you have to do some feeding, like you have to give labels to it and all. But no, if you want to have it learn on itself, you can just keep on feeding images and it will build its own model. So it need not be binary. It can actually do complex classification and other processing. So I think that's all we had. Let me go ahead and I'll pause again for the questions after some time. So this is how our application DAG looks like. So for when on top of Apex platform, if you write any application, it looks like this. This is the pictorial representation of any application which write, and this application we normally call it as DAG. DAG actually stands for Directed Acyclic Graph, and where the nodes of this graph, they are the processing units. We call them as operators in Apex terminology. So all these rounds you see circles, they are the operators and where all the processing actually happens. And these operators are connected by the edges, and these edges actually carry data from one operator to another. So if you imagine this, when you actually run this DAG, each operator will be running on a different machine. Or they might coexist on same machine, but they will be different processes maybe. So the data need to be forwarded from one processing unit to another to carry out different processing in stages. That's why we represented it like this. And this is the DAG for this for the deep learning application. So here you have input adapter, which reads all the data from outside system. Your outputs is outside systems could be, your input data could be like, for example, available in files. It could be coming to you from queues like Kafka or JMS, or there could be any other data source. So as I mentioned, we have a Malhar library, Apex Malhar, where you have a lot of such operators already written. You can just use it in your application. The next thing we call it as master operator. what it does, it actually there are two things it does. It actually to start with, it will generate a model using default parameters, and it will forward those default parameter model to all the workers available in your system or application. And also, whenever input data comes in, it will split the input data across different workers to provide you parallelism. After workers are done processing, they will keep updating their model, and as we talked about it, at some intervals they will forward their models to the parameter averager, where the averaging will happen, and you will get a consolidated or the uh, model, and that model will be given back to the master. So if you say this operator is called as delay, so in normal application in Apache Apex, you cannot have loops. You cannot have any back loops in your application. This is because this is a string processing. You cannot go back in streams in general. But for certain exceptions like doing machine learning and all, you need to feedback, give back some data or models for processing. For such purposes, we have this operator called, we call it as delay operator, which help us to introduce loop in your application. So the average parameters are sent back to the master. The master will update the worker node with this new updated model again, and the training will keep happening. One more thing, at the master, each time when you get a model, you can actually check its accuracy, and if it is satisfied, maybe you can write it to some file or somewhere so that you can consume it for scoring at any time. I think someone is having problem with hearing. Is it with everyone, or you can hear us? Okay, cool. I think others are able to hear me, so I'll go ahead. Mm. So this is the data set we experimented with. This is called as Iris dataset. It is a very small dataset, but this is the first one we did, and we are trying with a huge dataset of images for character recognition. That is the underlying, like we are in process of doing it right now. But this is the very first, and it is simplest to understand and see how it works. So we have a like three set of just a minute. So we have three kind of classes of flowers. The classes is versicolor, centosa, and virginica, and from each class we have a set of flower, like we have a few flowers characteristics which we feed into the algorithms, and those data characteristics or the character or that is in numerical format. So if you see, there are four kind of characteristics, and they are represented in numeric format, and this is the class name. So we give this labeled data as input to the deep learning algorithm. The deep learning algorithm will learn themselves, like what it means, like what characteristics could make a flower in this particular category. For example, if you see if you send this once it builds the model, and if you send a new flower, based on what it has learned, it will decide if it is a centosa class, or it is a versicolor class, or virginica class. So this model is built by itself by looking at this data set, and this is the actual real application which ran on the machine. So this application, as you see, there are three worker nodes. In real life, when you are working with really high input data, you can have as many number of workers as you want. It will give you parallelism factor. So your input data will come in here. Our data was available in files, so we use a file input data source. Then we forward this data to the master, where this data will be subdivided and send it to the each worker. This will also keep on passing the default parameters as well as the like updated parameters which it gives, and it will keep forwarding to workers. The workers will keep training themselves, and at intervals they will forward their models to the averager. This is a unifier. It will just unify all the data. The averager will send it back to the master. This is how, like, we are actually ran it in our system, and this is how the application looks like on our UI. And this is the accuracy. Actually, we just wrote our model to the log files. We did not do anything fancy as of now, but this is the accuracy we got. We got 98% of accuracy. And I'm sure if we train ourselves on a bigger data set, we will get a much higher accuracy than this. I just pause again for questions. Okay, there are no questions at this point of time. So these are few of the challenges. These are the few of the challenges we faced. So one was like Apex applications are actually packaged in a certain way. We create a Uber jar for Apex applications. There we have the jar for which actually holds your application code, and we also package some configuration and dependency along with it. And the dependencies are actually a dependence jar, and it's not the classes directly. But because the DL4J has native code, we had some native libraries, and it was not the application jar was not able to access them in the class path. So we had to actually change the packaging mechanism. We had to use a Maven shell plugin and do a packaging in a different way. Then so Apex by default uses a Creo serialization, but most of the classes in DL4J library were not Creo serializable. So what we did, we actually changed the serialization to Java. So Apex provides that capability. You just have to put some tags on the fields, and it will use the right serializer for serialization. So there are few these are very few small challenges we faced, but it was, I mean, provided the kind of complexity we were trying to solve, and using these two libraries, the platform Apache Apex and the DL4J library had made it actually extremely simple. And just to mention you, like some of the college students have worked with me on this project, and they have developed this in a really small amount of time, which is very impressive. So I think I'm almost done. I'll pause for the questions. Can you? The question is, can you please provide us with the basics that one like we should know what to get the expertise in this field of algorithm. Maybe I'll post some material to you or on the meetup page, Ankit. So when I started, actually I started learning from basics, like what is I had some idea of machine learning, but I did not know about deep learning. So I first understood what is deep learning. Then I looked into DL4J library. They also have a very good documentation. They have some videos around it. So go ahead and check that. And our course should be accessible. I hope I should be able to share with you guys, so I can do that as well. If you want it, please write me an email. I can respond to you with all the details I have. The next question is, for huge data sets, will the master be a bottleneck to split data? Are the workers capable of reading data directly for better parallelism, something like locality optimization? So the answer is yeah, it could happen that master could be a bottleneck if you have really huge data set. So there are a couple of things you can do. One thing is you can have parallelism factor in master itself. So in our experiment or the DAG I shown, there was only one master, but you can have multiple masters as well. But again, like you have to then no, that should be fine. Actually, you can have multiple master. Otherwise, as you suggested, having the parallelism at worker level, that also you can do. Your workers can directly read from the input data sources. So even that is possible. So what your DAG will look like, so if I go back just a couple of slides here. So here in before worker, you will have this input adapter before worker. And this master has to be maybe then before this, which will not interfere with data, but with just the model, and model are very small, so you need not worry about them. So yes, there are different ways you can address this, and if you use this platform, you will see like there are multiple ways we can address this. The next question is, what are the skills that a team need to deliver useful deep learning based products? So there are a couple of things. You need to have some understanding of machine learning. I don't think you need to understand the algorithms in depth, but you need to understand for what kind of use cases, which algorithms you should pick. And if you could stitch multiple technologies together, like we have done, like Apex and deep learning, your application actually can be done in very less time. I can guarantee you that. Like if you have good enough amount of expertise and you have basic knowledge, it's not that difficult. um, can you There's a question, can you show how DL4J library is used with Apex? Do you want to see the code, Rahul? If that is the case, I can share it with you. So in presentation, I have shown you how DL4J can be used with Apex at application level. So I have shown you the DAG. This was a DAG. So I have shown you running application screenshots and all. But if you need the code, I can share it with you often. So the next question is, will the presentation available online? Yes, we will share the slides on SlideShare, as well as the video recording will be available on YouTube. If you want to write to me, you can write to me at at priyanka@datatorrent.com, or you can write to me at priyag@apache.org. Code, actually I cannot show it right now, but I can share it with you later. Can you just write to me and I'll revert on your mail? Okay. Yeah, thanks for attending, everyone. And I'll just suggest you, like, if you are interested in Apex and all these things, so please subscribe to our mailing list. We have a lot of good communication going on this mailing list with respect to use cases, or even with respect to development problems people are facing, or the help. Then you can actually download this application. We have a free to try out application version of DataTorrent actually is a company who has written this Apache Apex open source platform, but we have a proprietary product on top of that, which is called DataTorrent RTS. You can download it and use it. It's free. We have a trial period, a trial license. You can try it yourself. Then you can follow us on Twitter. We have like meetup page. Keep looking for it for upcoming webinars. We post all the videos on YouTube, all the slides on SlideShare. And we also have a startup accelerator program. So if you're a startup and you're eager to use our product, we are happy to help. Please reach out to our team. And we have an app hub where we actually post the application templates we generate, which will be actually just download and use or try out to start. There is one more question. What does it take to be an Apache Apex resource? Huh?
What does it take to do Apache Apex resources? Subscribe to the mailing list and everything. Check out.
So I didn't get this question actually very well. To be an Apache Apex resource, do you mean you want to contribute to it? If yes, you can actually subscribe to our mailing list. Maybe start with the small Jiras which we have. You can actually post it in the community that you want to start it. Many people will respond you with will help you how to get started. The download link actually is mentioned over here, datatorrent.com/downloads. There you can get the product. You need to have Hadoop before that, just to clarify. Then yeah, I think that's all questions. I think I'll wait for 5 minutes if you have any more questions. Otherwise, we are almost done.